So in the last video we looked at the function that you call to do your device independent setup work, and you only call that function once per run of your app. And then in this video we'll look at this bit of setup work here, which is the work you do that is dependent. It is dependent on the device, but it's not dependent on the window, so it's window independent. So for example, if the device is lost, if something goes wrong with the display driver and you need to reset things, then this is the function that you need to call again under that condition. So let's take a look at the code. My version of this function, I call it do window independent setup because that makes sense to me, and like the comment says, this is the work that depends on the device but not on the window. So let's take a walk through the code and see what it's doing. The first thing we do is we create this flags variable, and we'll be passing that to the create device API a bit later on. We get it going, we get it started with this BGRA support flag, and that gives us interop with D3D. I'll talk about pixel formats for colors in a later video. The next thing is we decide whether or not we want the device to be single-threaded. This is another one of the create device flags. If we do choose for the device to be single-threaded, then we're essentially promising that we're only going to call the device from one thread throughout the lifetime of the app. And if I'm not integrating with XAML in my code, then I can guarantee that I'll only call it from one thread. If I am integrating with XAML, due to the nuances of the multi-threading that's going on in that, I haven't yet figured out how to put all my calls to the device on one thread, so I kind of weasel my way out of it under that condition, and I don't set to single-threaded. If this source code file, if this source file gets built into a Win32 version of an app, then I'm not integrating with XAML, so I will set single-threaded. If I'm writing a Windows Store app that's not integrating with XAML, then I will set single-threaded. So the only time that I actually don't set single-threaded is if it's a Windows Store app that is integrating with XAML. So now debugging. This is setting the debugging flag for the device. I mentioned that for D3D in the last video. So we've got this helper function here. Let's go into the helper function. All it does is it actually calls create device with the debug flag set and just returns whether or not that succeeded. So in this case we're not throwing an exception if it fails. We're just figuring out whether or not it failed. If it succeeded, then we know that we can safely call create device later on with that flag set. So we go ahead and OR that in. So feature levels, different display adapters and drivers have different feature levels that increase and get better over time as more features are added. So here what we're doing is we're listing the feature levels that we support in order of preference. So I'm going to put 11.1 first because that's what I'd prefer, and if the driver has got that supports that level, it'll tell me that first, and that's it, job done. Otherwise it'll drop down, it'll drop back and just tell me which one it supports out of the list. So now here's a couple of COM pointers, smart pointers, one for the device, one for the device context. This one happens to be an immediate context in D3D 11. These are Windows Runtime Library reference counted smart pointers. Let's look at how we actually use those. So here's the call to the create device API, and I'm passing in that device pointer, the address of the device pointer, and then the address of the device context. We talked about what the device and the device context were in the previous video. So just in one API call I get both those pointers back, both those interfaces back. This time of course I'm throwing if that failed. So now with my device I'm basically doing a query interface on it. Let me explain. So the actual version of the interface that was returned from create device was D3D11 device, but I've got this class member P D3D device that is actually an D3D device too. So I need to do a query interface on the D3D11 device to get that version 2 interface. And that's just the compiler's way of doing a query interface. It's essentially com's way of doing a safe cast from one interface to another. So now we've got our class member device, and then I actually just do a similar thing with the device context to take it from an iDevice context to an iDevice context 2. Just do a query interface on that. And then the rest of this function is really just about the D2D pieces. So we get hold of a DXGI device from our D3D device, and then we pass that into create device on that D2D factory that we created in the device independent setup, and that gives us our D2D device. And then we also just grab off of that D2D device, we grab D2D device context. And then this last call, this is I put a lot of the kind of scene management stuff into a class hierarchy called scene, and that also has window independent setup stuff in it. So you see this is named the same as this function, do window independent setup. So it just kind of delegates any scene related window independent setup to the actual scene types. But the stuff that happens in there is more to do with the actual graphics that you render on the screen, and not as much to do with setup. Or at least the kind of setup of the device that we've been talking about in this playlist. So I'll leave that until later. I'll talk about what happens in the scene when we start talking about actually putting graphics on the screen. So in the next video I'll move on to looking at the window dependent setup.